Hello, everybody. My name is Hercules. I'm a software engineer, and today I'm going to show you how a function really works under the hood. So, I have here an excellent website called godbow.org that exposes a compiler explorer that allows us to write a source code and to see on the right side the machine code generated by the language compiler. About the languages, we have here several different languages, but I choose C because I think that C has less noise between source code and machine code. Okay. About the code I have here is a small piece of code that basically adds two numbers. So here I catch the sum and store into this integer variable. Uh, so to understand how a calling function works on low level, basically we need to understand to know about calling convention. So the calling convention we have here is the system V calling convention that basically is the calling convention used by the Unix-like operating system. So if you compile your code to another platform, the calling convention may be different. Okay, so let's talk about the rule and why we need the rules. Uh, so we need the rules defined by the calling convention because in the machine code, uh, calling a function is just a jump to another area, another memory area of our program. So the rules define important things like how the arguments are passed. So the first rule we have here is that the six first arguments of a function should be passed through these registers. It means if we have more than six arguments, we should pass the exceeding arguments through the stack. So we have here these registers, and these registers are color saved, which means that these registers, if the caller function needs these registers, it should save uh, the value of these registers in the memory because these registers can be used by the callee function to perform its operations, and the callee function doesn't have the responsibility to restore the values, the original values of these registers. So these other registers are callee saved, which means that the callee function should restore the original value of these registers before finishes its execution. The next rule basically defines that the return value should be stored on this register. And the last rule basically says that the stack frame should be created and destroyed by the callee function. So based on these rules, let's see the machine code that defines our sum function and our main function. So basically, this piece of code, this piece of this machine code basically represent this statement. So the first step we have here, the first two operations is basically is storing the arguments values into these registers. These registers is a 32 bits version of these two registers. Okay, so next we have a call of a function that is just a jump to this memory area of our, and here we have this piece of code that is called a prologue. A prologue define our stack frame. Stack frame is a area in the stack where our function store its local variables, including the parameters. So because of that, we have the toNext operation that is moving the arguments from the registers to the stack frame. And because we have to perform operation over the A and B arguments, we need to move them from stack to this register. And here we perform the sum operation. Basically, we sum EDX to EAX and store the result of the sum in EAX. And EAX is the return register defined by the system v calling convention. So here we have the epilogue of our function that basically destroy our stack frame. And now we can return to the caller function. So we basically keep executing our code from here. And here we are catching the return value of the EAX from the EAX and storing to the main uh, stack frame. So that address is basically the result variable. So that's all about um, calling function on low level. There's many details about that. That's a summary, but that's very useful if you want to do things like reverse engineer. So leave your comments below. See you in the next video.